All right, we're return here. Your student professor, Dr. Dolphy Gilpin here, and we're on the periodic table, and we're looking at the first 25 elements, and we've reached up to the 11th element. So let's go to our pack, like Mission Impossible here, and we're going to select from our pack, since these are not in order at the moment, sodium with atomic number 11. So here, I got it right here. So we have plucked it out. Sodium, atomic number 11, atomic mass of 22.987. And for these early elements, we could almost double the atomic number and we get an approximation of the atomic mass in most cases. But as we go further up the line, sometimes this little law does not work. But for these elements in the first, like 2025, that little law works. If you want to have an idea of the atomic mass, we double the atomic number. Atomic number is like the number of protons or the number of electrons. And the atomic mass is the number of protons plus the number of neutrons. As we know, electrons also have atomic mass, which is sort of negligible, but as we go, then it does have atomic mass, and we could calculate that. So here we have it. Let's turn to a little book, notes. Sodium. I've written this little notebook here, and here's sodium now with atomic number 11 and atomic mass of 22.989. Electronics configuration would be neon 2s1. Ain't that so? Or neon 3s1. To be in the third shelf, because we have just completed the second shell with neon. So it will be in a 288 configuration. So it's like the electronic configuration of neon plus 3s1. One electron would be S shell. Now it's highly reactive, and a valency of 1, that 1 electron in the outer shell there. It's in the alkali metal group, and it reacts vigorously with water, a displacement reaction, to give hydrogen. Burns with a yellow flame in here. So sodium burns with a yellow flame in here. So sodium plus water, it will give you sodium hydroxide plus hydrogen, which is a displacement reaction. And as you know, it reacts very vigorously. Running on top of that water, it's less dense than water, I believe. And so it runs, you see it's run with fire on top of the water. That's sodium. And that's a highly exothermic reaction, giving off heat with a yellow flame running on water. So you also have now sodium plus oxygen. It burns in here, 2 sodium plus oxygen to give you sodium oxide. 20O. And then the sodium oxide is unstable, so it further reacts with hydrogen to give you sodium hydroxide. Sodium burns in here with a bright yellow flame, Na plus hydrogen, right? It can react with hydrogen, 2 sodium plus 2 ammonia. It reacts with ammonia to give sodamite. 2 sodium plus 2 NH3 give you 2 NaNH2. which is called sodamide, plus hydrogen. And also it reacts with chlorine to give 2 sodium plus chlorine gas, give sodium chloride, and it's an exothermic reaction as well, with a bright yellow flame burning to give chlorine. It also reacts with fluorine, as you know, with a similar reaction. Sodium plus fluorine give you sodium fluoride. So those are some quick characteristics, the properties of sodium, and some quick reaction. As you know, sodium chloride is that salt that is very important to our body, NaCl, and also deficiency in sodium in the body is hyponatremia, and too much sodium in the body would be hypernatremia. And that you will find that in endocrinology, though doctors specialize in that area, the deficiency in those things affect the endocrinology glands, sodium, hyponatremia and hypernatremia, and with difference in potassium, but that's for another setting. We'll just let that remain as such. And so here we have sodium in the third shelf, which is KLM. Here we have the M and sodium in the third period there, atomic number 11 and atomic mass of 22.989. So that's sodium. And we come over here, now a little notebook. Sodium with notes on sodium, and that's from our little deck of cards showing sodium.